Okay, so here we go for the second review for the final. Again, accent on the material for the exam one. Um, that's where we're putting the emphasis on here because you have so many videos for exam two and exam three, including review videos. Okay, let's bring this down. Let me do a better job at that. Okay. Now, our title. So I'm going to call it Math 105 Partial Review. Partial Review Final for the final. And this is the second one, so we call it B. We did 4 problems on that first one. Here comes problem, well, I'll just call it problem number 1 for each one. That's what we used to do. Let's keep to the same system. Okay, here comes problem number 1 for this B, for review B. If you have a problem that looks like this, the square root of negative 32 over the square root of negative 8. We learned a long time ago, back in exam 1 material, that you can put them all under the same square root, negative 32 and negative 8. And that makes your life easier because now this becomes the square root of 32 divided by 8 is 4. Negative divided by negative is positive. It's the square root of 4. And what's your final answer? 2, or plus or minus the square root of 2, depending on how much they want to be careful about. So if they really want to be careful about it, they'll say plus or minus 2, and maybe they'll just have the number 2 there. I can't guarantee what they'll have. It should be plus or minus 2. Okay, and that's it. Problem number 1 is done. Here comes problem number 2. What if you have this following radical situation? Square root of negative 15 times the square root of 20. So here's what I suggest to do. Break this down into pieces. The square root of negative 1, but we're going to do it a little faster than we used to. I would not the square root of 15, which is true, but I'm going to start breaking it down into 3 pieces right away. Square root of 5 and square root of 3. That's all true. Negative 1 times 5 is negative 5. Negative 5 times 3 is negative 15. It breaks up. What about 20? I'm going to break it down into just 2 pieces. The square root of 5 and the square root of 4. 5 times 4 is 20. 4 is a good one because that's a perfect square. I should have put 4 on the right and 5 on the 4 on the left and 5 on the right, but that's okay. All right, what can we do with this? The square root of negative 1 is going to turn into an I. We always learned that the I is going to be on the left-hand side of the square root sign, of the leftovers, but I will belong on the left. So we did that one. The square root of 4 is the only other perfect square, is the only other perfect square among the candidates here. The square root of 4 becomes a 2. I put that on the left-hand side, not with the leftovers. The square root of 5 times the square root of 5, we learned the square root of 5 times the square root of 5 is 5 itself. It's a whole number. It's a regular number. It belongs over here. It's trying to multiply whatever's happening here. So those are gone. Square root of 5 times the square root of 5 is 5. Belongs over here. And the square root of 3 is the leftover. What do I have? What's the finishing touch to this? 5 times 2i is 10i. Square root of 3. Problem over. This thing is done. Okay, number 2 is done. Let's do number 3 right next door before we move the paper up. I don't have to move the paper up yet. Okay, so next, what if you have a problem that looks like this? It's another quadratic equation problem. It's the third. We had 2 on the previous in A. In review final A. Now in review final B, we've got our first quadratic. 4x squared minus 48x equals 0. How do you deal with this? There's only 2 here. There's not 3, right? So it's not factoring the 3, but we're still going to factor. We're going to bring out the GCF, the greatest common factor. 4 goes into 4. 4 goes into 48. So bring out the 4. Bring out the smallest of the x's. There's an x greater than x. Bring out the small. We've done GCFs many times. 4x squared divided 4x turns into x. Minus 48 divided by 4 Positive 4 is minus 12, and x divided by x cancels. So here we go, equals 0. Now set up the T formation, which we've done many times before. Set up 4x equals 0. Divide by 4 on both sides, you get x equals 0. Here's our first answer to the quadratic equation. And set up x minus 12 equals 0, and we're doing this a little bit faster, plus 12 on both sides, so it's x equals 12. Here's our second answer. There we go. That's it for this problem. Now, moving up the paper, want to take advantage, if we can. Let me bring it back down now a little bit here. Okay, good. So, let's go over to this side, draw the curtain here, so to speak, and this too. And let's see what we can do with the last piece of this paper. Of course, I got to get this done under 15 minutes because of YouTube. Okay, so here is our next example. 16, a to the negative 3, b to the 6, c to the 7, divided by 2, b to the negative 4, c to the negative 11. Now, let me remind you of something, one of those old rules. Let me remind you. Remember that x to the 5 times x to the 2 is equal to x to the 7. X to the 5, right? I could have reminded you about this before. We had a problem like this in A. X to the 5 to the 2 is going to be x to the 10, power to a power, right? And then what if you have x to the 10 over x to the 3, then you subtract and you get x to the 7. And now what if you subtract a negative number, negative 8 is equal to positive 8. All right, so it's going to happen over here. Hold on, bear with me. 16 divided by 2 is going to be 8, and it belongs on top. 16 wins, so it's going to be on top here. A to the negative 3 puts it on the bottom. It's the same thing as 1 over a to the 3, so it lands on the bottom, right? Remember that fourth rule? The fourth rule was x to the negative 2 equals 1 over x to the 2. I put up those 4 rules so many times when we were back in the classroom. So that goes along with what about this negative 4? 6. This is this is exactly analogous to this one. 10 over 3, 10 minus 3. 6 minus 4. What's 6 minus 4? It's 6 plus 4, which is 10. So B10 belongs up here. 7 minus 11. 7 plus 11. That 7 plus 11 is 18. C18 belongs up here. And this problem is over. Okay, a little bit more time, I hope, and a little bit more space. Problem number 5. What if you've got 12x minus 4y. This is really exam 2 material, but okay, we're going to see it anyway. I made an exception to this. And the question is, they want to know what, we keep this out of there. They want to know what's the slope, what's the y-intercept, and they want a graph. So we've got to isolate y. So we got to get rid of negative 12x on both sides. Negative 12x on both sides. Got to isolate y. This is gone. I got minus 4y is equal to negative 12x plus 4. Put the x first and the plus 4 second. We've mentioned that many times. We still got to isolate y. Divide by negative 4 here. Divide by negative 4 here. And divide by negative 4 here. This is gone. Y equals, negative divided by negative is positive, so it's going to be 3x. And 4 divided by negative 4 is negative 1. Here's our slope. Our slope is 3. It's not even a fraction. And our y-intercept is 0, negative 1. Y-intercept. The graph. We talked about this briefly. All right, plot your point, 0, negative 1. So 0, and then go down negative 1. Here's 0, negative 1. 0, negative 1. Right there. And what can I do? How can the slope help me to graph? What is the slope? The slope, in other words, is 3 over 1. Right? 3 is the same thing as 3 over 1. Now, what's the top? The top is height. The top is up and down, and the bottom, right? Remember the formula for slope. M is equal to y2 minus y1 over x2 minus x1. This is the height. This is left and right. Okay, the height is 3. Go up 3. 1, 2, 3. And then move over to the right. This is positive, so move over to the right. 1, right here. I've got 2 points now. I connect them, and I got this thing graphed. This happens to be the point called 1, 2, and it's move over 1, so it's 2, 1 is the point. All right, let me write that a little bit better. This point is called 2, 1. Okay, we end this video. Let's move on to our next stop.